Welcome back. Today we're going to talk about multivariable systems. This is section 6.3. And what's involved in a multivariable system is we've talked about two variable systems. This is going to be one where we have three variables. And so what we're going to be doing is we're going to be doing a little bit of elimination and a little bit of back substitution. There's a couple of strategies involved here. And what I'm going to do is I'm going to generalize it for you. Number one, you're going to have three equations. And so you're going to make two pairs. Okay, and so what you'll have is you'll have equation A, equation B, and equation C. And so you're going to pair up A and B, and you're going to pair up A and C, or B and C, or however it works out. And you're going to eliminate the same variable from both sets. So for example, you pair up like A, B, and A, C, A and B, and then A and C, and you're going to eliminate X from both of them. So you're going to do linear elimination, kind of like we've been doing elimination, but you're going to eliminate X from both pairs. And what that's going to do is it's going to pare it down to where you only have two variables that you're working with. Okay, and then you're going to solve the two variable system. That remains. Okay, because you're eliminating one of the variables, so let's say you take out X, well then you've got Y and Z. Well, now you have two equations with two variables each, so it's a regular linear equation where you can eliminate one or back substitute or whatever we got to do to solve. All right, so here we go. Here's a system, an example system. And what we're going to do is we're going to solve this one. Notice we have three variables, x minus 2y plus 3z, negative x plus 3y equals negative 4. And then we've got 2x minus 5y plus 5z equals 17. And so what we're going to do is I'm going to pick pairs from here, and I'm going to pair up these two first. So I'm going to start out with x minus 2y plus 3z equals 9. And to that, I'm going to combine these and try to eliminate something. So I'm going to put under negative x plus 3y, no z term here, and then equals negative 4. Well, when I combine those, that's a good choice because I've already got the ability to eliminate the x. And so when I combine these, what I'm going to have is, no x, but then I'm going to have y plus 3z equals 5. Okay, y plus 3z equals 5. Now I'm going to take my other set here. And so I've got negative x plus 3y equals negative 4. And down below I've got 2x minus 5y plus 5z equals 17. Now I've got to combine these in such a way. I already eliminated x over here, so I'm going to eliminate this x. So what I'm going to do is multiply this first one by 2. So that's going to give me, a 2x or minus 2x and a 2x that match up. And so my new equation is going to be minus 2x plus 6y equals negative 8. And I'm going to combine that with 2x minus 5y plus 5z equals 17. This isn't too bad because, as you can see, all I'm doing is I just pair them up and now I'm eliminating one variable. I eliminated x in the first one, so I'm eliminating x in the second one. No x. And then I've got y plus 5z equals 9. Okay, so this gives me two new equations. This is what I've got left. Now my system that I'm going to solve is y plus 3z equals 5 and y plus 5z equals 9. And so this is what I'm going to end up solving, this system. And the easiest way to do that would be to take this one and multiply it by minus 1. So the new system that I'm going to solve is y plus 3z equals 5. And I've got negative y minus 5z equals negative 9. When I combine these, y goes away. I've got negative 2z equals 4 equals negative 4. And so when I divide by negative 2, I've got z is equal to 2. Well, notice, this is really good. That's 1/3 of my answer right there. And so now what I'm going to do is I'm going to just back substitute. And so I'm going to take this equation here, and I'm going to say y plus 3z, which is 2, equals 5. Well, y plus 6 equals 5. And so y equals negative 1. That's pretty cool. Back substituted in to get there. Well, now I can solve any of these equations to find out my answer. And so let's just pull out this one. So I've got negative x. It just has two variables. That's why I picked it. So negative x plus 3 times negative 1 equals negative 4. And so negative x plus negative 3 equals 4. Negative x equals negative 1. And so x is equal to 1. What's my solution set? My solution is an ordered triple of x, y, z. So 1, comma, negative 1, comma, 2. So x, y, z. Make any two pairs. Eliminate the same variable from both, and then work on a linear elimination using those two that you have left. Back substitute, and you're good. A lot of steps potentially, but stick with it, and you'll be able to eliminate one of those variables and pick them off one at a time. Thanks for watching, and we'll see you next time.